So ladies and gentlemen, we are to find the solution of the ordinary differential equation at x is equal to 0.2, and we are given the ordinary differential equation as dy dx is equal to 3x plus y, and the initial condition is x naught equal to 0, y naught equal to -1. The step size is going to be 0.04. So we are going to use Euler's method to estimate this value of the function, okay, given its ordinary differential equation. So we know that according to Euler's method, yn will always equal to yn minus 1 plus hf, xn minus 1, yn minus 1. So where xn is equal to xn minus 1 plus h. Now, we know x naught is equal to x naught is equal to 0 and y naught is equal to -1. So what is f of x naught and y naught? This is going to be 3 into the value of x, which is 0, plus 1 into the value of y, which is -1. And this is giving us -1. So if we substitute in the Euler's formula, so y1 will be y naught plus h f of x naught y naught. So this is going to be y1, which is equal to -1 plus 0.04, because the step size is 0.04. We multiply by the value of x naught, y naught, which is -1. And this is giving us -1.04. So remember, what we have just obtained is y of x1, which is equal to y of x1, which is 0.04. Yes, because our x1 is equal to 0 plus 0.04, which is the step size, and this is 0.04. So let's look for y2. y2 will be y1 plus h f of x1 y1, whereby x2 is equal to x1 plus h, and this is going to be 0.04 plus 0.04, and x2, okay, x2 is equal to 0.08. So we are looking for y of 0.08 at this value of x, and this is going to be y1 is known as -1.04 as calculated above, plus 0.04 times f of x1 y1. What is the value of f of x 1 and y1? This is going to be we have 3 into 0. X1 is known as 0.04, so 0.04, then plus y, y1, which we obtained as what? We obtained that as -1.04. So y2, which is equal to y of 0.08, will therefore equal to, this is going to be 1.0768. So let's proceed. We want to look for y3, which is the same as y of x3. But what is x3? This is the same as x2 plus h. And this is the same as 0.08 plus 0.04. And that is 0.12. So we move. So y of 3 will be y2 plus h f of x2 y2. And y3 will be, y2 we already know it as 1.06768. This value, remember, it's negative. So this is negative. So plus h, which is 0.04, times 3 into x, which is 0. X3 is given as 0. X2 is 0.08. Then plus y, which is -1.0768. So So what is our y3? Y3 is going to be negative 1.1103. So finally, let's look at y4. Y4 is equal to y3 plus h f of x3 y3. But what is x4? This is the same as x3 plus h. This is equal to 0.12 plus 0.04, and this is 0.16. So we are close to the value that we are looking for, which is 0.2. So we proceed. Let's get y4. This will be a negative 1.1103 plus h. H is 0.04 times, we put in the value of f of x, y. So the value of x, y is going to be, of course, x3, y3 is going to be 3 into what is x3. x3 is 0.12, 0.12. Then, obviously, plus negative 1.1103. So if we substitute in our value, then y4 is going to be let's calculate for it. So the value here is negative 1.1403. So let's look at y5, which is the same as y of x5. But what is x5? x5 is equal to x4 plus h. That is 0.16 plus 0.04, which gives us 0.2. So we are looking for y of 0.2. Okay? And therefore, that's where we are stopping according to the question. So y of 0.2 will therefore equal to what is y4? y4 is negative 1.1403 plus 0.04 times the value of the f of xy at x is equal to x4 and y4. So 3 into 0. Obviously 16, okay, plus what the value of negative the value of y4, which is negative 1.1403. So finally, y of 0.2 is approximately equal to negative 1.1667. So, and if we wanted it in 3 decimal places or 2, so it can be negative 1.167 to 3 decimal places. That is y of 0.2, approximately copy that. Because that is what we were asked to calculate for. When you look at it, is 0.2. So that means we have carried out about 5 iterations. Thank you.